take a look at problem number 7. So on the main board and right behind me, I'll go over it, dim the lights a little bit, set us a little nice ambient. All right, so we have y equals 7x minus 13. And then we have 6 comma blank. And then we have, oh, I was looking at that problem. I was trying to get that right in there. All right. So talk to me. Talk to me. What do you think? What do you think we should do? And then also, while we're taking a look at that, make sure phones are put up. Mine's up there. What should I do? What do you think? Yeah.
Try to get the x by itself.
Okay, I like your thinking. Get the x by itself. But hang on, it says up here, it says determine the y value of each ordered pair based on that. So I want the y value by itself. So let me, can I build upon what you had said? You said get the x by itself, but this one they want to get solved for the y. So is the y by itself here? Okay, so we just kind of flip-flop that. Do you see a little mistake, but it's okay? Cool. And then what else? What do you see? Go ahead. What do you want?
You're gonna actually multiply 6 by 7.
Okay, so this is an x value, so it's going to go in there, right? So I get, and when two numbers are next to each other, what does that mean we're going to do? Multiply. So that's going to be, I think that's 29. Okay, so that's one answer. So this is a point, right? Like if I had the xy axis, I could plot that point. But, you know, I'm just trying to foreshadow what we might see later. What should I do with this, the 1? Yeah.
1 times 7.
Yeah, so you're just going to do the same thing that you did with the green, but you're going to plug a 1 in rather than the 6. I love it. So 7 minus 13, so that's negative 6. So both of these are the answers. So those both gave us points. So sometimes they call the excuse me, the x value the input, the y value the output. Okay, so it's just a matter of how you want to progress with that. So the same thing is done for number 8 and number 9 and number 10. Does anyone need to see 8, 9, or 10 worked out, or do you feel that by seeing this, you could tentatively go through and work the rest of those problems? We okay? Okay, let's take a look at 11. So I know a couple of people had some challenges with number 11 because it's like, hey, what should I do with this? And that's okay. So they have the x value they call the input, the y value, and then they have 1, 2, 3, 4, 5. All right, so let's do this one in green. Let's do this one in red. Let's do this one in purple. Let's do this one in, ooh, that's a cool green. Let's do this one in a really fun neon green. And then let's do this one in a pink. Okay, so do you see how the 1 went in for the x, then the 2 went in for the x, 3, so on and so forth? And then you just have to do the arithmetic. So 3 times 1 is 3 plus 5. This gives me an answer of 8. 3 times 2 is 6. 6 plus 5 is 11. 3 times 3 is 9. 9 plus 5 is 14. 3 times 4 is 12. 12 plus 17 and 15. That gives me then 20. So something I want you to see here, though. 1, 2, 3, 4, 5, all in order. Agree? So look at this. Remember we were talking about patterns last week? Look how these grow. So remember when we were able to discover if there was a pattern? Well, the 1, 2, 3, 4, 5 was all sequence. And then we could plug numbers in and get numbers out. So that's basically how 11 and 12. Now, friends, I want to steer away from number 12. I'm not going to worry. That's a silly question because you're dealing with your letter being your exponent. So 4 to the first is easy. 4 to the second we get away with. Then you get 4 to the third, 4 to the fourth, 4 to the fifth. 4 to the fifth is a huge number. Like, that's a yucky problem. So skip 12. Let's not worry about 12. Okay? And then we had some review down at the bottom that says that mixed review at the bottom, right? So the mixed review, down at the bottom we have 2 plus 3, 9 minus 4 squared. And then we also have, I can't see that. Should be another thing in parentheses overhead. All right, that one's, I'm going to put, that one's yucky. And I don't want to do it. So I'm not going to assign you a problem like that. There's no reason to go do a problem like that. But let's go back to this one. Order of operations on this board. Should I go 9 minus 4? Or should I go distribute 3 over the parentheses? Or should I square the 9 and square the 4? What do you think? Yeah, we're going to take care of 9 minus 4 first. Thank you. To get to there. Agree? What's next? Should I go 3 times 5 or should I go 5 squared? 5 squared. What is 5 squared? What's 5 times 5? 25. So remember, 5 squared is equal to 5 times 5, right? And then we'll do the math. So we come up with 77 for an answer. Okay? And let's skip 14. That's the... I don't know what the teachers... I didn't write this part of the book, so they were being crazy when they did that. Okay. All right. So let's take a look in the packet. Okay, if you have your book, we're on page 7, or if you have your packet. And if you need to get the book, there might be some time today I could send you down. If not, you really do need to get that book. Get it from the bookstore. It's $3 from Bare Necessities. Let me just make sure I have these pages. Yeah, I got it. Plenty. Anyone else still need a packet because you don't have it? The bus trample on your packet too? Everyone else good? Everyone happy? You didn't need? You need one?
This is the same thing, right?
Yeah. Okay, and again, you really do need to get that book. I mean, we're going to run out of time. We're running out of pages in this book.
Is it supposed to be like this? Like broken apart?
Yeah. We want you to put it in a 3-ring binder. Okay. So is everyone, you found that page, whether it's in the packet or in your book? We're good? We're good? We're happy? Okay. So, ready? So I'm going to show you something. If I have y equals, and this is not on your paper, if I have this, or I have this, they mean the same thing. Those two, they mean the same thing. One is just in a term called functional notation. So that means the same thing as y for all intents and purposes. I mean, once you get onto calculus, it might mean a little different, but for right now, we're okay just saying if I have f at x or if I have g at x or I had h at x, these all mean the same thing. Okay? So this is just called functional notation. It just means the same thing as y. Okay? I got the hiccups. Pardon me. All right. So I want to give you all some time to work, but the very first problem, they want f of 1 for a, and they tell you that the equation, if I could see that far. And I also want to do b. Okay, that's both a and b. Ready? All right. I have a 1 right here. That means I'm going to replace this with a 1. So I'm going to go 8 times 1 minus 3. So I'm going to get 8 minus 3, which is 5. So f at 1, that's your answer. Yeah.
Where did you get that from?
I got the problem from the worksheet. Or are you meaning like why is it different than y equals?
Why is it 1?
Oh, so on letter 1, or letter A on the practice, they wanted you to do f at 1. Okay? And they have it as f at n. It's called functional notation. I think, to be honest with you, I think it's the place where math used to be this high society type of thing, like back in the 1400s, and I think they developed it so they could confuse the rest of the people. I kid you not. Like, I mean, I'm being totally honest. It's like, but they changed, basically what they did is they're replacing y with f at x or f at a letter. And that just means replace the variable, which is a letter that's inside the equation.
So it's 1 every time?
Oh, so in this case, they said, hey, what's f at 1? If you look on the worksheet, in the middle of the screen, it says f1. Okay? But if you look at B, it says g negative 4, right? You looking at B? It says g at negative 4. So watch this. Ready? This is going to go and replace this to look like that. This is where n used to be. That n could be an x, could be a g, could be any letter. So then here we just go, okay, that's negative 12 minus 10. So that's negative 22. So f at, or g at negative 4 is negative 22. So this is the answer. Okay? So friends, would you take about 5 minutes and try to do C and D and then A, B, and C on the next one? See if you can figure those out. Talk with your neighbor. All right, so on this particular problem, this 0 right here is going to replace that. bless you, this 5 here is going to replace that n. So that's where the replacement takes place. Okay, so on this first problem, I'm going to get 3 times 0 minus 10. And 3 times 0 is what? 0. And if I 0 subtract 10 is what? Very good. So there's the first problem on the front board. Second problem, let's do the same thing. Again, I'm replacing the n, but I'm going to replace the n in this case with a 5. And then 8 times 5 is 40. Subtract 3, so that's then 37. Okay? Hey friends, fist to 5. Fist to 5 on those 2 problems on the front board. You feel comfortable with what I did? Even if I had to talk you through it a little bit, give me up to a 5 if you feel good about it. Give me a fist if you're bad. Give me anywhere in between. I got some 5s. I got some 5s. Got a 3. Okay, I'm going to come back on your 3. Your 3. Where are you stuck? Which one? Top or bottom or both? Both? Okay. So are you following on the very top problem with the G? I'm going to replace the N with the number 0. Okay, that's what that 0 is on the left side. So you just move it over and you realize if you had 3 and N next to each other, 3 and N are being multiplied. So I have 3 times 0 in that case. And so 3 times 0 gives me 0. And then 0 subtract 10 gives me an answer of negative 10. And it's the same thing for the next one down. The 5 replaces the N. So 8 times 5 minus 3. Yeah. Yes. Yeah. All right. Are we good with those problems up there? Oh. That one. Oh, that's a different class. Oh, gotcha. Go for it. Friends, may I move forward? Okay. So the next problem we have looks like this. This is letter A, I believe. So I'm going to replace this 1 for this n. Now realize that n is an exponent. So watch what's going to take place here. Try to get something creative and it just didn't work for me. Yeah, it's supposed to be an F. This is F at 1. Okay, so I'm replacing this here. So I'm going to get 3, 2, and just raise the first. So 2 to the first power is just 2. And then multiply to get 6. So this answer is 6. Okay? Can I move on to letter B? So for letter B, I'm going to replace 1 with an n right there. So that means that I have 8, 5, and 5 raised to the first power. Well, 5 to the first power is just 5. And then multiply so I get 40. So the answer to this one is 40. Okay? We good there? Fist to 5 on that problem. Fist, nothing, 5, everything. Everyone ever in between. Fist 5, got a 5. 5. Fist 5, I'm getting 5s, getting 5s. Okay, gotta crack my back, hang on. Oh, best day ever. Okay, may I move on? All right. Eyes to the board real quick. I'm going to replace this with 0. Uh-oh. I'm a little concerned about this. Because this is 8 times 5 raised to the 0 power. We've not talked about the 0 power. Does anyone know what 5 to the 0 power equals? Not 0.
5.
It's not 5. It's 1. Okay? So, I'm gonna highlight this. I want you to just take a look at this. This region right here the answer is 1. And then I'm going to multiply that by the 8. Okay, 8 times 1 is just 8. This is a very different concept, the concept of an exponent being 0. I'm not going to get into the schematics of it. So watch my pattern. Ready? 0 to the 0, undefined. 1 to the 0, 2 to the 0, 3 to the 0, 10,000 to the 0. All right. So if you have 0 raised to the 0, it's an undefined term. Don't worry that's undefined. Just note, kind of keeping the back of your head, undefined. Any other number raised to the 0 power is going to be 1. Okay? So that's where this 1 came from, right here. Okay? Can you make it work that if you see something raised to the 0 power, almost every time it's going to become 1 unless it's 0 to the 0 that's undefined. But I'm going to make sure I don't give you 0 to 0 because that's like a really weird wackadoodle idea. Last problem. What should I do with that 4? What should I do with the 4? What should I do? What would you like me to do? What should I do here? Where should that 4 go? Yeah, the exponent. Very good. All right. So this is going to be 3, 2, 2 raised to the 4th power. So that means you have to understand that 3 to the 4th, or 2 to the 4th is 1, 2, 3, 4. Okay? So this here that means the same thing as this. Good? And let's do some math. Ready? 3 times 2 is 6. 6 times 2 is 12. 12 times 2 is 24. 24 times 2 is 48. So this answer is 48. So F at 4 equals 48. Okay, it's called functional notation. It's a different idea, but I don't know if it's entirely impossible, but if it's starting to look like ants walking on your paper, it's okay. Just take a breath. We'll get through it.
Sí, sí, porque vamos a la primera potencia de 2. La primera potencia sería 1.
All right. I'm going to duplicate this little map. All right. Because I'm the teacher, do you trust me for a moment? All right, ready? Ready? I'm going to highlight. Okay? Ready? So does everyone agree that that top table goes along with A, B, C, and D, those problems below? First thing, are we okay with that? You following what we got on the worksheet? All right, ready? Okay. Take a look on this front board. Notice I highlighted F at 9. I highlighted the 9 in parentheses. Agree? Take a look at our table. I highlighted the 9. And what is the output with the 9? It's highlighted. 32. Oops. I don't know why I did that in the dotted. That 32. Friends, can you make this work? I had a 9 here. If I have a number of parentheses, I'm going to go up to my table. I'm going to find the top one, 9. That 9 right there. Then I want to take it down to the 32. Okay? Now let me pause for a minute. Do you feel comfortable with what I just did? So don't look at B, look to C. Does C look a little tiny bit different than the A or the B, how it's written? Do you agree? All right, you see this 22? Before with the 9 I went to the top to find the number. Now I'm going to go to the bottom. I'm going to find the 22. And what's the number that stays with the 22? 7. So this is 7 for an answer. Okay? So, my friends, I feel with that, I think that you can complete all of the rest of page 8. Agree? Okay, so kind of look at the table. Looks like the ones on the bottom, you're maybe trying to find the pattern. So I think you could deal with that. But why don't you take the rest of the period, try and work on the rest of page 8. Excuse me. If you get it done, no homework. If you don't get it done, spend no more than 5 minutes outside of class finishing it. Deal?